All right, welcome to another episode of DGX Compare. This is part 3 of a 3-part series on models on a cluster. So in part 1, we did Llama 3.1 as an 8 billion parameter model, and just wanted to showcase the speed with clustering, but on a model that really doesn't need all that much clustering. In number 2, we worked on the Nemotron 120 billion parameter quantized down to 12 billion parameters. That could actually fit in a single node, but it's under risk of crashing because of memory utilization. And for this third and final video, we're going to be working with a model that's actually very difficult. In fact, I don't think you can actually fit it into a single node because it's 230 billion parameters. So this is the MiniMax 2.7 quantized with NVIDIA floating point 4. And it's actually quantized down to, I think, 9 billion. But yeah, the model itself is 230B. So yeah, without further ado, this is the lead node, this is the worker node, and yeah, let's watch the GPU utilization. And the query will be tell me about Komodo dragons here, and then over there it's going to be tell me about rhinoceros. Misspelled. All right, let's go. So there we go, 96%, 95% over there. This is a thinking model, so it's actually beginning to think. Wow, look at that. Prefill is actually pretty fast. Let's check out the token speed. It's reasonable. I'd say that's probably, I don't know, 15? Probably 15. It's working, and I would actually use it. Let's take a look at, wow, look at that. All the cores are definitely running on the worker node, and GPU's at 95%. Since this is clustered, they're equally working. Yeah, a lot of stuff going on right now. But yeah, so this is, I've heard a lot about the MiniMax models, and this is fine-tuned for the Spark. And that's it. Komodo dragons remain one of nature's most fascinating apex pictures. Would you like me to dig deeper into any specific aspect? I'd say no. Oh, there we go. Just waiting for that. Are Komodo dragons, are they endangered? Do Komodo dragons have unique physical features or abilities? Okay, let's click on that, trigger it to work, and I'm also going to do multi-user experience. So now that is also doing a query, and let's see how it's going. This is at 106 gigabytes of RAM usage. That's 103, and they're both at around 95%. This is thinking, and that's thinking. Notice the thinking was a little longer here than earlier, and that's probably because they're working on there's actually multi-node usage. This is already started. That is still thinking. Okay, there we go. Komodo dragons over here, rhinoceros over there. Let's check the heat. It's okay. This is a little slower. That's probably looking like, I don't know, 10, 12. It's still usable, but not great. Yeah, memory utilization, system memory are pretty, pretty bogged down now. That's actually already completed. Let's do a follow-up over there just to kind of trigger. I'm waiting for it to pop up the follow-up prompts. It says, would you like more details on any specific component or aspect? Yes. So think about it from a business situation. So you're two separate developers. One is working on the actual server itself. One is working on a remote machine. They're both being used as part of the cluster. With this much memory allocated to the actual model itself, it's in trouble. I don't think you can actually work and do anything else because, I mean, you only have, what, 20 gigabytes of RAM available right now and 17 over there. And essentially the GPU is at 95%. So any kind of additional work is going to go down to disk and it's going to slow a lot of things down. If you look at all the cores here, again, it's extremely busy. And imagine you're trying to compile something. Let's say you're actually trying to get help from the model in terms of code development, and then you're now going to grab whatever help that you got and pasting it into, say, Visual Studio. Yeah, that's not a great experience there. So let's follow up here. What habitats do rhinoceros live in? What kind of Komodo dragons are found in the wild? Again, they're both still thinking. So parallelism works. The pipeline parallelism, I think we put pipeline parallelism PP is equal to 2. Tensor parallelism is equal, actually not even in there because these are separate GPUs. But anyways, the model is able to be launched. You're able to grab information from the model. It's running at a not so great speed, but usable. And yeah, this is just kind of like a quick demo of what it's like to be able to run a large model inside of a cluster. Whereas, let's say you drop this into a MacBook Pro or a Mac Studio with only 96 gigs of RAM, you wouldn't even be able to load up this model. So thanks a lot for participating or viewing our videos. And yeah, go back to evaluate video 2 and video 1. But if it were me, I think I would probably stick with the 120 Nemotron. I think it's a good balance. And you would still have a lot of memory remaining to work on other things. All right, so yeah, MiniMax 2.7 NVFP4, 230 billion parameter model quantized down to 4 bits.